Our next Fast 5 is going to cover functions. Functions can be any type of functions, linear, quadratic, higher degree polynomials. I've noticed there's a lot of function notation on SAT tests, so I want to make sure we cover that in particular. So this question's great. So we have this linear function f of x, and if 3 halves x plus b, and they give you 2 clues. So go in order of the clues. It's usually the way they want you to work. This clue says, if you were to plug in x equals 6, then you would get an answer of 7 for the function, an output of 7. So let's go ahead and do that. Let's take the function, which is 3 halves, but instead of x, we're going to call that a 6. And then plus some mystery number b. I have no idea what that mystery number is, so let me just set it up that way. And then I know the answer is supposed to come out to 7. So let's see what happens. 3 halves times 6, that would be, and this is no calculator by the way, so that would be a 9. So 9 plus mystery value of b equals 7, so b is negative 2. Now don't circle negative 2 because that is an answer. That's not what they want though. Go back. And it says now take your whole function and plug in negative 2. So now that I know b is negative 2, so plus negative 2 would be minus 2, now they want me to go back to this function and plug in a negative 2 into the function itself. So 3 halves times negative 2, and then minus 2 for the function. It's a lot of negative 2's. That was by design, by the way. So 3 halves times negative 2 is negative 3, minus 2 is negative 5. Ooh, these questions can get pretty tricky, right? The concept that they wanted you to apply wasn't bad, but nasty answer choices on purpose. All right, this one. They want you to take negative 3x, place it into your function, and then come up with a new function. So negative 2 times now negative 3x plus 5. And then just watch your simplification, guys. This is an easy question. Positive 6x plus 5. Look at the choices. Again, by design, 6x plus 5 is choice B. And this one, they want you to build up the function, or they want you to pick which function here works for this table. This is really an XY table. I think the easiest way to do this for most kids is just to go through the ordered pairs and kind of mark off the ones that work and the ones that don't. Now, you got to be careful. If it works for the first ordered pair, don't just get excited and circle an answer. You got to keep going. So if I plug in a 1 to each function, let's see if I can eliminate anybody, because I'm supposed to get an answer of 5 according to this table. So 2 times 1 plus 3 is 5. All right, so that one's good. 3 times 1 plus 2 is 5. Good. 4 times 1 plus 5. Yeah, good. 5 times 1, 5. Good. Okay. Well, I say good, but that's kind of bad because I can't eliminate anything yet. Let's keep going down the table. I'm actually going to go to the end of the table. I know the way they design these is that if you're using this method of plugging and chugging, they're going to make it as painful as possible for you. So I'm going to plug in x equals 5 and see if I get an answer of 21. X equals 5? No, not 21. Gone. X equals 5, that is 21, so that one's good. X equals 5, that is not 21, gone. X equals 5, that is not 21. The answer is C. So because I'm kind of aware of the trickery that they're trying to pull on me, I'm not going to fall for their trickery. All right, so here we have an exponential function. But they're going to do what's called a transformation to this exponential function, and when they throw a negative in front of the function, that's a reflection across the x-axis. So this function in particular is a growth function, and if this is on a graphing calculator, you can figure this out pretty quickly if you forgot, but it has been shifted up 1 unit, and it looks something kind of like this. So if I reflect this over the x-axis, it's going to end up looking not like that, kind of like that. So choice C. But let me show you an algebraic technique to think about this. If you throw a negative in front of the function, so this entire function is going to have a negative thrown in front of it, right? And this, a lot of kids get this wrong because they don't realize that negative gets distributed to not only the initial part of the function, but also to that vertical shift. So what used to appear as an up 1 shift is now actually moving a down 1 shift. So this function becomes negative 2 to the x power minus 1. So it's still a growth that's been reflected, but then it's been shifted down 1 unit. The horizontal asymptote is now at negative 1. So that is why C is the correct answer. A lot of kids think D is the right answer, but that's why they put that there. It's a distractor. All right, there's your Fast 5 on functions.